Hey everybody, we're multiplying and dividing monomials today, and we're working with properties of exponents. All right, we're going to write equivalent expressions using properties of exponents and discover properties of exponents. Our only vocab word is monomial today, monomial, and it's a number or variable or a product of numbers and variables. So I'll give you some examples. 4, just the number 4, sitting all by itself, that would be a monomial. X by itself, monomial. Or we can have a product, that means multiplication of a number and a variable, or a number and one or more than one variables. Okay, so it could be something like this. All right, you could even put a little power up there. The key is only multiplication is allowed. Somewhat division, but mostly multiplication. All right. So product of powers property, well, this is just saying that you're going to be multiplying product of powers, so that's a base and an exponent, and this is a property that relates to those two. So let's say we have in numbers 2 to the 4th times 2 to the 3rd. All right, there's a way to simplify this. Now, in your head, you might be thinking, well, 2 to the 4th is 4 2's. And 2 to the 3rd means the 2 is used as a factor 3 times. So 4 2's and 3 2's, so that would be 7 2's. If you thought that, that's awesome. You're on the right track. What the property says is that you keep the base and you simply add those exponents and you get a simplified version of that product to be 2 to the 7th. All right? So what we say here is we say to multiply powers, keep the base, add their exponents. All right, let's try it with algebra. So that means we're going to use letters. All right, so let's say we had a to the m times a to the n. This is just saying it in a general way. So then what do? So we have to look for this. It's multiplying, and we have the same base on both sides. So on both sides of that multiplication. So we keep that base, and we take the two exponents and we add them. So that's m plus n. Now, since m and n aren't like terms, we can't simplify it anymore. So that's just the final result, a to the m plus n. All right. Now we're going to skip over quotient of powers property. That's going to be saved for later. We're going to dive into this a little bit just to show you. I'm going to be quick though. Write as many different expressions that you can think of that are equivalent to this statement, 2 to the 4th times 2 to the 3rd. All right. So for instance, you could write it out like this: 2 times 2 times 2 times 2 times 2 times 2 times 2. Right? Because we have the here 2 to the 4th, and we have over here the 2 to the 3rd. So that is what we call an equivalent expression because it would come to the same answer. It's just written in a different way. All right? How about this one? This will be tricky. What if we group those 2's a little differently? What if we said 2 to the 2nd times 2 to the 5th? Well, that would be 2 times 2 times 2 times 2 times 2 times 2 times 2. All right, is that the same thing? Sure, it still gives us 7 2's, or the 2 is going to be used as a factor 7 total times. All right, so that would give us the same answer. And there are so many different ways you could do it. You could do something like this: 2 to the 3rd times 2 times 2 times 2 times 2. Well, how many times is 2 used as a factor there? We have 1. Whoops. We have 1, 2, 3, 4, 5, 6, 7, right? So that's still 2 to the 7th power. All right, so that's our little way of understanding kind of why we can add the exponents, right? Because those exponents tell you how many times you'll use the base as a factor. All right, so we could do the same thing here with the x squared and the x to the 5th. You could write it out. You could have 2x times x That's the x squared, and then you're going to multiply that by x times x times x times x times x. And you notice that there's 1, 2, 3, 4, 5, 6, 7 total. So that would be x to the 7th. All sorts of different ways to write it. So we could go x to the 3rd times x to the 4th, because that's going to give us x to the 7th. X times x to the 6th. That's tricky. Wait, why is that x to the 7th? It looks like just x to the 6th. Well, if a base does not have an exponent, we just assume it's a 1. Right? So there's 1x as a factor there, and then plus 6x is used as a factor. And that gives us that total of 7 x's. All right, so that's a little bit behind the rule. Now we're going to practice. All right, pause, try this one and see if you get it, and then unpause and fix. All right, here we go. We got the 5 squared times 5. If we write it out like kind of expanded notation, we get 5 times 5, that's that part, right? And then we're going to multiply it still by another 5, so then altogether that's 5 to the 3rd. Okay, now it says specifically using the laws of exponents simplify these. They don't want you to actually get the answer. They just want you to use the law of exponent that we worked on up here. That's this. That says basically keep the base, add the exponents. All right, so that's all we're doing right here. All right, so then a short way to say it, instead of writing all the 5s out, we could say 5 to the 2nd plus 1, which equals 5 to the 3rd. And that's what the format of the answer, that's how we want it written, a base and an exponent, okay? Be careful. If a factor does not have an exponent, then we just can slide a 1 in there, and that's going to be how we roll. All right, next one. C to the 3rd times c to the 5th. We can just quickly, you can pause, see if you can get it, and then come back. C to the 3rd plus 5, and that's going to be c to the 3 plus 5, so that's going to be c to the 8th. All right, so we keep the base, we add the exponents. Now, if you have to do it the long way, then you know that c to the 3rd means c times c times c, and we have the multiplication that was in there originally, and then we have c to the 5th, c times c times c times c times c, and you see that, you get c used as a factor 8 total times, so that's going to be c to the 8th. Oh, now we have number 3. So this is the first time we've had other integer factors mixed in. So numbers that are all being multiplied as well, besides actually mixed up. The numbers and the variables are mixed up here. So the thing that a lot of people first notice or first think is that these are like trapped together, and you have to deal with them all together. But the thing is, even though the 4 is like next to the x, it doesn't mean it's trapped together. It just means that that's multiplication in there. We could think of it as having a dot in there. Okay, so let's write that out a little bit more expanded. So that'd be -3 times x squared times 4 times x to the 5th. Now that it's separated, you can kind of see now that it's easier to use commutative property, move the integer factors, so the non-variable factors, together. So 3 and 4 can go together. And then put the common bases next to each other. So that's be x to the 2nd and x to the 5th. Now we can just simplify. We can simplify this just through multiplication. That's going to be -12. And then we can simplify this part using our exponent rule. So since they have the same base, we can keep the base and we can add that exponent. 2 plus 5, so it gets you -12 x to the 7th. All right, that's a really important one to pay attention to. And that's the simplified version right there. Okay, let's pause this. Oh, make sure you fix B. It's written wrong maybe in your notes. I'm not sure if it got copied as right or wrong for you, but check it and change it if you need to. All right, pause, come back, and then we'll do these last 3 before you move on to your homework. All right, should be back, and you should have tried these. Since you have multiplication and you have common bases, we're going to keep that base and we're going to add the exponents, and we get 9 to the 5th power. All right, a to the 3rd times a to the 2nd, keep the base, add the exponents. That gives us a to the 5th. And, ooh, this one is tricky. So we have to realize that even though we have parentheses here, multiplication is associative. So that means you can move those parentheses and move the factors all around and you'll still get the same answer. So we're going to use this to our advantage here and make it a little easier. So if we had -2 times m times -8 times m to the 5th, all right, we just spread it out with those multiplication symbols. It helps us realize that the -2 and the -8 aren't attached to the m's officially, and we can move them around using commutative and associative properties. So let's get the -2 and the -8 over here, put the m's next to each other, and we can simplify that part just with multiplication. So that gives us a positive 16 because a negative times a negative is a positive. And then we have an m with no exponent. What do we do? Hopefully you said put a 1. All right, m to the 1st and m to the 5th. So that's m to the 1 plus 5. So that's 16 times m to the 6th. And there we have it. All right, that's the lesson. Good luck in your homework.